Okay, so I'm going to have a look at synaptic transmission. So here we have a pre-synaptic terminal and a post-synaptic terminal. So there we go. Pre-synaptic terminal and post-synaptic terminal. So what happens here then? So the presynaptic terminal gets all excited by an action potential. So you get an influx of Ca2 plus calcium. So Ca2 plus, so an influx of that. Okay, an influx of calcium. And that's via voltage-gated channels. And what this does, these here are vesicles, okay, full of neurotransmitters. And here we go. Give them some neurotransmitters too. So, what happens next? So you get the influx of calcium via the voltage-gated channels, and these cause these vesicles to bind to the presynaptic terminal membrane. So that would be this bit here. So these little vesicles, they travel along. There they go. So they get in here. Right. So that's the presynaptic terminal membrane. And then these neurotransmitters empty out into the synaptic cleft. So the synaptic cleft is this bit in the middle. The gap, very, very small gap between two doodahs. Presynaptic cleft. So this happens, so these, yeah, they get all spooged out, they're released, and this is called exocytosis. Exocytosis. So they are released by the presynaptic terminal into the synaptic cleft. So these neurotransmitters bind to and activate the postsynaptic terminal, what they called receptor sites. So they get all in here. Add a few more. So whether or not an action potentially actually occurs depends upon the sum of like inhibitory or excitatory neurotransmitter that actually make it across the synaptic cleft. So yeah, there we go, that's that. So yeah, you're not guaranteed, because this has happened, to get an action potential. It depends on the sum of excitatory versus inhibitory neurotransmitters that make it across. So these ion channels open. So these ion channels open, and they accept the neurotransmitters. And this is your postsynaptic terminal. And these neurotransmitters can continue their merry way and potentially make an action potential. So, we said excitatory versus inhibitory. So, I'm going to put this. So, what are our excitatory neurotransmitters? Neurotransmitters. Well, let me tell you. They would be we have got glutamate, which is a neurotransmitter in the brain. And then we've got acetylcholine. And this would be at the neuromuscular junction. So 2 different types of neurotransmitters dependent on where the synaptic cleft is. So that's excitatory. So what's our inhibitory neurotransmitter? Inhibitory would be, where's my red pen? One called GABA. And that's in the brain. I like to remember GABA being inhibitory because it's inhibitory and it stops you going GABA, 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 GABA. So that's that. That's how that works. So what happens with these leftover neurotransmitters? So they make their merry way across the across here. What happens afterwards? Damn, I've just got permanent pen on my white shirt. What happens afterwards? If they're not all used, all these neurotransmitters, they can either dissolve essentially via diffusion, or go back into the presynaptic terminal in a process called reuptake. And that is that.